Hello, Calc students. Today we'll be discussing the product and quotient rule. So the product rule, if you're taking ddx, which is the derivative of a function which is defined as f of x times g of x, the derivative is equal to, I like to think of it as first derive second, so it'd be first the function times the derivative of second, so it'd be g prime of x. First derive second plus second, which is g of x, second derive first. Derive first is f of x, so it'd be f prime of x. So this is the general form for the product rule. So for example, let's do 2x times x plus 3. Obviously, you could just find the derivative by distributing and taking it that way, but we're going to do it the product rule way. So the derivative, if this is what f of x, if f of x is equal to this function, f prime of x, which is the derivative, is equal to first would be 2x first times the derivative of second. Derivative of x plus 3 is, the derivative of x is 1, derivative of 3 is just 0 because it's a constant, so it'd be times 1. First derivative second plus second, which is x plus 3, derivative first. The derivative of 2x is 2. Then we can continue to solve. So 2x times 1 is just 2x plus 2x, because you distribute this to here, and then this to here would be plus 6. It should be equal to 4x plus 6. So this would be the derivative of that function. Now moving on to the quotient rule. If you're taking ddx, the derivative of the function that is defined as f of x over g of x, then derivative is, what I like to think of it as is bottom, which is g of x, bottom times the derivative of the top, so f prime of x, minus, not plus, minus top, which is f of x, times the derivative of the bottom, which would be g of x, g prime of x, sorry, over, this is the important part that many people forget, over bottom squared, should be over g of x squared. Now let's put this into action. So let's say you have a function that is defined as f of x, just imagine that says f of x, equals 2x squared plus 4 over x minus 3. So to find the derivative, it would be f prime of x would be equal to bottom, so bottom would be x minus 3, bottom, derive top, so derivative of top would be 4x, right? Because you distribute, because of a power rule, so take the 2 down, so it'd be 4x plus 0, since 4 is a constant, so it'd just be times 4x. So bottom times the derivative of the top plus the top, which is 2x squared plus 4. So bottom derive top, correction, this should be minus, this should be, sorry about that, this should be minus, so it'd be this, minus, sorry about that, so it'd be bottom times the derivative of the top minus the top times the derivative of the bottom. Derivative of x minus 3 is just 1 over x minus 3 squared, so this is bottom squared. Now you can just simplify everything out, which should be 4x squared minus 12x minus 2x squared minus 4, because you distribute the negatives, over this whole function here, which is just x minus 3 squared. You don't have to distribute it out. I usually don't, but if your calc teacher requires it to be distributed out, then you could do that if you need to. Then you just take like terms right here, these two right here, so it'd just be equal to 2x squared minus 12x minus 4 over, the denominator is the same, x minus 3 squared. And there you have it. That is the derivative of this function. Now, that's it. So now I want you to put this into use with these two examples for the product and quotient rule. So example number 1 for the product rule. I want you to do the product rule for this product right here. X squared plus 3 times 3x cubed minus 27. And that's the product rule one. And then the quotient rule one, I want you to do the quotient rule for this one. I'm going to show you to give you a combo. It's going to involve a product and a quotient rule. It's going to give x squared plus 3 times x minus 3 over x minus 4. I want to see if you can get that. So just drop your answer, and yeah, that's it. So there we covered the product and quotient rule, and as always, subscribe, and if you need any more math tips, just reach out to me on YouTube, and yeah, thank you.